show that 1 over root 5 plus root 6 plus 1 over root 6 plus root 7 plus 1 over root 7 plus root 8 is equal to 3 over 2 root 2 plus 5. Okay, so what we need to do is to each of these, we're going to rationalize the denominator. No, so to rationalize the denominator, what you need to do is you look at the denominator here, we've got root 5 plus root 6. And then you do root 5 minus root 6. And because you're going to multiply the denominator by that, you must also do the same to the numerator. So in the numerator, we're obviously just going to get root 5 minus root 6. And then here we have what's known as the difference of two squares. So we know that a plus b times a minus b is a squared minus b squared. So that will become root 5 squared, which is 5, minus root 6 squared, which is 6. And then we're going to get root 5 minus root 6 over minus 1. Then similar idea for the next one. So again, root 6 minus root 7 this time, the same for the numerator. We're going on the numerator, we're going to get root 6 minus root 7, 6 minus 1, again, 6 minus 7, sorry, which gives minus 1, and then in the numerator you've got root 6 minus root 7, and then the same for the last one. Okay, we've got 1 root 7 plus root 8, so we're going to do root 7 minus root 8, same for the numerator, so that's going to give root 7 minus root 8 over 7 minus 8, which gives me root 7 minus root 8 over minus 1. So we're going to take these 1, 2, 3 things. So the original sum will now become this. Root 5 minus root 6 over minus 1, plus root 6 minus root 7 over minus 1, plus root 7 minus root 8 over minus 1. Now we know for adding or subtracting fractions we need to have a common denominator. We now got the same common denominator, minus 1. So that's going to give me root 5. Obviously, minus root 6 plus root 6 will cancel each other out. Minus root 7 plus root 7 will cancel each other out. And we're going to end up with minus root 8. What we're going to do is now rationalize again, but the numerator, we're going to rationalize the numerator. So we've got root 5 plus root 8. We've got root 5 plus root 8. So in the numerator, using a minus b, a plus b, we've got a squared plus b squared. We're going to have 5 minus 8, and then here we're just going to have minus root 8 plus root 5. I'll just turn these round the other way. Doesn't matter because you're adding, but kept the minus sign outside. 5 minus 3 gives me 5 minus 8 gives me minus 3. In the denominator, we've still got minus root 8 plus root 5. Now, root 8 is the same as square root of 4 times 2, and therefore the square root of 4 becomes the square root of 4 times the square root of 2. The square root of 4 is 2 root 2. So the minus signs cancel out, and we end up with 2 root 2 plus root 5, which is what we were required to show. Okay, so this has been a video to show you how to simplify a more complicated surd and show that it's equal to something else using rationalization. And I hope you've understood, and I thank you very much for watching.